Okay guys, let's talk about design. So I'm not a designer per se. I don't really identify as a designer. I'm more an entrepreneur that a lot of my work involves design. So I'll get that out there. I do think that design is very important. I do have some formal design training from when I went to engineering school, but I don't consider myself a designer. That said, I do have a lot of real world experience when it comes to design, and that's what I want to talk about. So I was requested to make face masks, face shields, like this one. I'll get into this one in a little bit, by my sister-in-law, who is a physician in the Bay Area, California, and she's dealing with a lot of these cases and a lot of other doctors and nurses who are also dealing with this, and they have no PPE or very limited PPE at her particular hospital. There are people that are swabbing people for the COVID-19 test that have nothing but gloves, and that's very concerning. So she asked me if I could make masks or help her, or face shields. I keep saying masks, but face shields. If I knew anyone in California who could help make these. I reached out to some people, didn't get much good feedback, and so did she. And that's what I want to talk about first. Is a lot of people, I'm on Facebook groups, on Reddit groups, are talking about making PPE to help contribute. And I think that as designers and makers and manufacturers, that's amazing. However, I'm running into this problem, and so is she, where she has run into a lot of people who she asked to make this particular face shield. She has the material. She said, hey, do you have the equipment to make this face shield? Will you make this face shield for me? And they said, no, I'm sorry, we're not going to make your face shield that you're requesting, but we're working on something ourselves, and we'll have it to you in a couple days or a couple weeks. Now, I really appreciate the generous spirit behind that, but as designers and makers and manufacturers, we have to understand that we can do our key part, and right now is not the time to let our egos get in the way. And if we're being asked to make a specific design, let's just go with that design. Now, this design in particular came out of NYU. This is part of the OpenFacePPE. If you're watching this and you don't know what PPE is personal protective equipment. I don't know if it's used so much in the medical side, but industrial side, everyone says PPE. But in this case, we're calling it PPE because it's shorter. Now, this face shield was designed in an inter-department effort at NYU. And I think that it's really, really well thought out. And I'm going to dig into this design a little bit. But there's a couple key features that make this really good. One is it's very easy to manufacture. This can be made out of almost any clear plastic, and it can be made on a variety of different machines. I made this on a roll feed friction roller sign cutter, vinyl cutter, made by Graphtec, with a 60-degree blade, and I didn't screw cut it. I pretty much did a very deep score around it and then popped it out. This could also be made in the ideal machine to make it would be a flatbed CNC controlled cutter that uses a drag knife or maybe a laser. It could also be made in a smaller CO2 laser cutter. It could be made really even in a vacuum hold down CNC with a mill end cutter. It could be cut with scissors. There's a lot of different ways that this could be made, and it can be made very fast. Even if you were to cut these out with a pattern on a cutting mat and a knife, one person could still probably make dozens of these an hour. I've seen in these Facebook groups and Reddit groups that a lot of people are going towards having this forehead support piece being 3D printed. And they say, well, theoretically, if I 3D print it and it has more of a cover, because this has an open space, if it has more of a cover that covers stuff from coming in from the top, that's going to be better, right? Yeah, it's going to be better. But I've seen designs that look really cool and people feel really good about, but they take 5 hours to cut, or I'm sorry, to produce on an FDM 3D printer. And 5 hours right now is not time that we can afford. Now, I'm not saying you shouldn't do it if that's the only equipment you have, but if you're a manufacturer or a maker and you can already computer cut these pieces, that's really what you should be doing, because even if this is only 80% good and you have a design that's 90 or 95% good, this can be done en masse, and it can be done today, and it can be done very quickly. your slightly better iterative design, if it cannot be executed on now, isn't going to help the situation. And honestly, when I first saw this from NYU, I had the same reaction, right? Because I do design work and I'm always trying to improve things. I looked at it and I said, oh, you know what? If we made this top section taller and then cut scores in it, and I had tabs, it could be linked, so it's kind of more concave at the top, that would be better. And I was right, it would be better, but the thing is that also makes it more complex, and right now simplicity is key. This right here can be flat pack shipped. This is what 100 of them look like. This is 100 face shields in a box, going flat rate express one day to Oakland, California, where that 3D printed piece, I can't fit 100 in this. There's no way. I maybe would fit a couple dozen. This is really inexpensive. I think, buying the material at retail with slightly inflated prices, this face shield with this piece of elastic O-ring is less than $1. If you were able to buy material in bulk, you're looking at pennies. So I'm going to continue this video with some instructions of how I made it and how it gets assembled and how I'm packing them. And I'm sorry that you had to watch this kind of long rant, but I think that there is a distinction between people who design for work in the real world, whether that's their profession or hobby, but are actually designing in practice, and with people who are designing in theory. And I think a lot of the people who are working in the theoretical space right now kind of have to get over themselves, and let's move into the practical space, and let's all try to help in the ways that we can.
So what you're seeing now is this Graphtec sign cutter, vinyl cutter. These are used in the sign industry, and the carriage there has a blade in that, right where you see that blue piece there. So this is currently cutting the face shield part. You can see kind of the larger area, and then the headband next to it. And here we have a couple extra headbands. You can see how this material is kind of scored, so I'm popping them out here. The blade isn't cutting all the way through a can, but with a roll feeder you don't want it to, because it will screw up the feed. So it's just kind of 80-90% cut through the plastic, and then you just kind of have to use your hands to pop them each out.
Okay, so this is how these go together. These are your three main components here. You have your band, you have your forehead support, and then you have your shield. We're taking this O-ring, I just had a knot on it. This could be elastic, whatever material you have. String seems to even be used where people are desperate. I'm going to talk about how sad that is. But feeds through both holes like this. And then it's pretty much just the opposite on the other side. And I think that this is one of the although it might be perceived as a weakness in some ways, I think that this is going to be a huge pro, that this is very easy to assemble. These headband pieces might break, but I don't think that is a big concern. I've just been cutting extras because they're so small. So depending on how big your holes are, the holes are better a little smaller, because I think that people are going to be finding that they're going to be finding smaller elastic. So this is how this works. You see how that forehead support, because it's a shorter length between centers of your holes than the holes on the actual shield, you end up, it kind of holds this as a dome to remove it from your face. So this is how this goes on. With an O-ring, I don't know if this will work with elastic, but I don't even need another knot. This just kind of holds it here, and you can kind of pull it tighter. But you can see here where you have enough room to have a mask, to have goggles on. And you do have some open access here. I believe The doctors that I talked to said that most people are wearing like kind of like a hairnet, so this area is actually going to be pretty enclosed, and this isn't as big of a concern as some people think it is. And then mask on the lower part. So functionally, these seem to be meeting all the criteria that the doctors that I have talked to have needed. The OpenFacePPE project has DXF files on their website. I found that they didn't work for my purpose. I'm running Flexi, running a Graphtec cutter. I tried just converting those DXF files into Illustrator files. That didn't really work because how the paths were drawn, it was all kind of weird and disconnected. So what I'll have a link in the description of this video on the files that I used. I have Illustrator files that are cutter ready, whether you use Corel or whatever, they should be good. And then I'll have the Flexi files as well. So if you're running a similar cutter, it should be ready to go. I'm in this basement of this building is all storage, but I needed a place to temporarily set up this cutter. So please excuse all the mess that's going on here. It's just a lot of garbage.